Hello everyone, welcome to the second episode of this week. Today we are going to look at the task number 2, which is called Interleave string. And here is the definition. Right, so you are given two strings A, B, and C. Write a script to check if C is created by interleave A and B. Print 1 if check is successful, otherwise 0. So there's an example. XY, and the second string is X, and the third string is this one. So we can concatenate a part of the A and B so that, or completely the whole A plus B, well, B plus A, so that we've got C. So, but nevertheless, so yeah, so that's the explanation. But if, for example, if you will take the example number 3, so YX, X, 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 Y. So it's not possible to put X somewhere inside or outside of the first string to get the result, right? So it's 0 here. And this one, XXY, XXZ, XXX, XZY. So yeah, so the first task, the first string, we take a couple of characters from the first string, XX. Then we take the whole string B, so we put it inside. And then we take the rest of A, so that we get C. So that's the definition. Okay, let's look at the solutions. And let me start with the last solution in this list today. So it's Ulrich Rieke, rock number 2. So yeah, here's the code. Let's make it highlighted. Well, not that much. So yeah, so there are three strings. You determine the length, interleaved A and B, or probably some strings, just prepare some space for them. If the strings are of the same length, right, so what you do, you split it into characters. You split the second string into characters. You just then make the zip with string concatenations. So yeah, and you do the same, but in different order. Yeah, that's the question that I had. So it's not quite clear from the definition, from the task, if like it should be solved symmetrical. So like if we only put B inside A, or if we also put A inside B. So that's the question. Okay, otherwise, if the first string is bigger, longer actually, then you do the same, plus you concatenate some string. Basically, yeah, you concatenate just the rest of the second string, right, which is longer. And the same in the opposite direction. And after that, so if this interleaved A equals C, or if the right, so if the second attempt gives you the C, then you print 1. Right, the only thing that we don't see here is that we don't see actually, so we see that it could be done, but we don't see the potential combinations, right? Okay, right, so but I want to take a couple of so these are the examples. Probably this is the best example that I want just to save somewhere. XXY, XXZ, and let's run the solution. Raku, Ulrich Raku 2, no, 2. So XXY, XXZ, what was there? Yeah, here it is. 1. So if, for example, I will insert A here, it will give 0. Okay, right, so let's go next. Let's go next, and the next solution here is the solution by Roger Bell West. Right, so what we have here, a few test cases, and the interleave function, which does the job. It gets 3 strings. S is so yeah, S is the thing of so we take each of the strings and we split it into characters, and we've got basically array of arrays, right? Yeah, this is another array, like these square brackets. Array of arrays, and the inner arrays are characters. Then this is the lengths, I believe. Well, actually not the lengths, but the array containing the last index of the strings, basically kind of length minus 1. Some buffer. While this buffer is not empty, we take something from that. But I wonder, yeah, okay, so here we push something. And if yeah, so these indices correspond to the strings A, B, and C, right? So this is C. If this is bigger than length, then we are done. Otherwise, we try more things. So yeah, to push this, so if there's some condition, so if some lengths are not long enough, right, then we, and if the if some characters inside these strings, right? So basically here we just by doing the second index, so this first index corresponds to the string A, and the second index corresponds to the character in that string, in the original string, right? And the same here, but it's with C. Right, we push, what do we push? We push 3 characters, not characters, but positions to the buffer, and we also do, would not return from function here, would also do this for if we see that the character, the current position, not the current position, but just in the first position, yeah, equals to the character from the string B, equals to that character from the string C. Okay. Yeah, I don't understand how it works, but nevertheless, so yeah, I believe we can just run it. Raku, Roger, West, Raku, Ch2, and just provide it with the same output, input. Yeah, we don't need input. Our input is completely ignored, but yeah. Right, it works. Okay, the next solution, Myoungjin Jeon, Raku number 2. So here's the solution. Tested with, right, the result looks like 1, as we found 6 possible options. Can we decompose these? Okay, so yeah, that's what I wanted to see actually. Yeah, I want to see the combinations, but nevertheless, all right. So that's long. That's too much, I think, for the review, but nevertheless. So we take the strings, we used some singleless variables, length. If the length is not the same, we immediately, that's smart. We don't have to try if the lengths do not follow this equation. After that, so we find some cases, and if there are no cases, no interleave, right, so we print 0 basically, otherwise we print 1 and something else. Yeah, and also we try to find to print all the options, right? Okay, so here is all possible partitions. Where is it? So all possible partitions. So we take the strings, right? So wow, SPS is another function, right? Right. Make permutations with repetition and filtering to divide a given sum into smaller natural numbers. Note, still need to sieve after work to get right result. Right, so this is the first helper function. Yeah, is valid. And interleave, where's the first one? So all possible partitions. Yeah, no, I cannot understand that. I will just run this. But yeah, actually, yeah, so this classification, I believe it's a bit Raku, Jeon, Raku, Ch2, and this output. No, again, I call it output, but this is input. Right, that's right. Okay, this one. So yeah, this is very good result. I really like that. But if, for example, I will take this, yeah, so it's this result. So the output I really like. The solution probably is a bit quite complicated. Right, so XXY. So yeah, this is basically how maybe we can so XX from the first string and Y from the first string, right? Then we put the second string into here. Okay, so this goes actually even more. Like, for example, look at this. So we just not only insert the whole string B into some position at the first string, but we just try to probably keeping the order of the characters, try to insert all those characters from the second string into, well, actually between the characters of the first string, right? This is like these examples, basically these are about those. So there are more than 3 parts and in the maximum it's 6 spots, like 6 characters in those 2 strings. Okay, that's why the solution is quite big. But yeah, it's not for the review, definitely. And you see, so there are like reduction operators, all these shift things, useless, signalless, even that. And maps, yeah, so there are many Raku elements, but it's too difficult for the review. Okay, the next solution here in the list is solution by Julio de Castro, Raku number 2. Right, so actually, yeah, the program is big, but actually the most of the program is just some test cases, but the function is quite small. And so it starts here, right? If there are 3 elements, you just print the number of elements returned. Well, I don't know if it's the number of elements, but just some numerical version of the return result. But what do we have here? So right, so this is a smart thing to start with, because if the first string is, actually I don't know if it's really needed there. Actually, yeah, I think I have this in my solution as well. Well, not like that one, but yeah. So we swap the strings if we see that the first string is shorter, right? Then, alright, some flags. And so here we start with a regex replacement. And we replace it with nothing for 0, 1. And this 0, 1... for 0, 1, basically we that's that's the way to repeat the thing twice, right? Because we make some assignments here. Wow, that's difficult. So A has A and false initially, right? No, actually it's already true. Has B true. How does it work? So this is a call block which is inside the regex, and there's no alternative right here. The same for the second string. So we matched the third string with that and see if we basically removed everything, because we are going to remove everything from the string, right? Okay, I see now. Now I see it. So if we managed, but I still don't understand how, like, to make this interleave. So, and if both regexes were basically both code blocks inside were triggered, so basically if we manage to match C with $A, and after that we manage to actually I think it's doesn't solve the task, right? Or does it? Okay, so Raku, Julio de Castro, Raku Ch2, and this, where is the correct one? I believe somewhere here, right? Right. There's no Raku. No, there's no Raku. Right, so it found the solution, but this one doesn't. So it solves the task, right? I don't know how. What we have here is, so maybe just let's run this, right? So why not? So here is, actually I copied but I never used this. So, and maybe let's just interleave of xxy, xxz, and this third string xx, right, zx, zy, right. So let's run it first. Raku t, so it should print. So yeah, I cannot. Maybe is copy. is copy. Now I can change those. Right, and I have to print this. So okay, so this is why it's yeah, but true and false also good, are also good. Right, I want to see maybe. So this is not defined OR operator, right? This is the continuation of S. That's why we can do it like this, right? And like that. Yeah, well, yeah, almost. So here it is, and now I want to just look at what's there, right? Something like that, for example. Raku T. Yeah, so we have some input already there. Right, so, okay, let's look. So after the first, so this happened, yeah, so originally the $C variable contained 6 characters, and after the first match, the first replacement was regex. We've got 3 left, and what we basically got out of that. Okay, now I understand that. So we just took this, okay, and probably maybe say has A, has B, right? Right, false, true. So yeah, so first the B variable was removed from the string, and what we've got is just the initial X, the second X, after that XX, Z were removed, and Y is left. And on the second, well, that's cute. That's interesting stuff. So basically, yeah, right. So yeah, so that's clever. That's a really good solution. So that's a really interesting solution, at least. So cool. So so we try to find just the place where we can just take and pick away the string, one of the strings out of the string, $C, and after that, actually what's left should be either that or that. Probably it can be even simplified. So like, for example, you remove that, and after that, yeah, actually you don't need this, right? And after that, what's left, basically, yeah, this is the result, right? What's left should be either A or B, right? So we can use the junction here, but actually not, right? Because if we removed A, we have to check that we got B. Okay, yeah, so yeah. So something like that, right? So this is the result, or we have to repeat this thing again, but with different things, right? So yeah, that's again. So basically the true result, true, is either this or that. Okay, yeah, nice. Really, I really like this solution after I understood how it works. Okay, the next solution. So it was Julio de Castro. The next solution here is Jaldhar Vyas, Raku 2. So we take 2 strings, we assign them to variables, local variables, and after that, so if there's at least one character is at least in one of the strings, because we are going to modify them. Basically that's the thing that I kind of just explained, right, in the previous solution. So what we have here is some string A, then 0, then C, well, literal 0, well, it's not the character, it's just the code position 0. Yeah, and Raku can work with that. Wow, that's cool. So if, no, actually it's not what I explained, but so if, so you take this string and you try to remove the prefix so that it repeats there, right? Yeah, and after that you do that with the second string. So what you do, so you take the prefix, it's here, so we expect, oh, but actually, yeah, I don't understand why. So we expect that here in the first string, which is A, so here is A, right, and this is C. Basically, yeah, we can just read these regex from the end. So if we can find in A something, in the beginning, which also is in the beginning of C, right? And this is the prefix. Then we remove prefix from both strings, right? And we do the same for the second string, and if the result is C, but actually it's not equal, right? But yeah, then it's 1 or 0. So this really needs to be run Raku Jaldhar Raku 2 and some input. Where is the correct input? Here, I believe. Right, this is 1, this is 0. Ooh, infinity, I believe. Okay, yeah, so right, so okay, nevertheless, so it's playing with so all the game is attached to the beginning of the first string and actually to the beginning of the second string, right? Because we immediately expect something after the 0, which is in between the strings. So yeah, it precedes the second string actually. And after that, we remove that prefix from A. So this is the prefix and this is the prefix, right? And from C. And we expect that after this replacement, we've got this C for some reason. But we already removed this, right? Okay, so after removing... No, this is a result we can... yeah, okay. Okay, now I see, because this capital C is the original string, and what we are doing here, we remove it from the copy of the string. Why do we need that? Because we repeat the loop, right? This is the repetition, and we repeat the loop, and basically this $C lowercase will be smaller and smaller on each repetition, right? And we repeat it until there are some characters left in either. Okay, now I understand that. But nevertheless, so yeah, it does not return if the string is completely incorrect, right? Okay, but it works for the correct case. Right, the next solution here in this list is a solution by Colin Crain, Raku number 2. What we've got here a couple of, 3 strings. We print them and we return them. Return 1 if, unless any of we've used all our letters. Sorry, yeah, so it's not main, right? So main function starts here, right? And Interleave is here, and apparently because of this comment, and yeah, we can immediately see that this is the recursive solution. So right, so basically this is where we start, and we actually immediately press 0 if the lengths do not pass the first simple test. Right, so for A and B, so we scan the first string, and then we scan this, we use the second string. $_ is the current string. When this string starts with the first character of the third string, then we taking the substring of the current string, A or B, right? Then the other thing, if this equals A, this one, right? Then you take this, otherwise you take, then you take the second string, and otherwise you take, okay, so you basically try to understand. I don't understand it. If this is A, okay, that's the other thing, that's the way to get the opposite string, the second string for each of those, right? Yeah, probably it's not that clear, but okay, now it's clear. So the target is the first character of the last string. Is there any difference between this and that? I wonder. Raku. So ABC substr 01 and ABC substr 1. Right, so this is the ABC substr 0, ABC substr 2, ABC substr 3. Yeah, so basically this is the rest starting from that position, right? So this starts at the 0th position, this starts at the 1st position, so BC, this starts at the 3rd position, thus C, and this is basically, this is the start, this is the length. I would say actually it's quite inconsistent in this design, right? Because it's the same argument in the same position, but it means a different thing depending on the number of arguments, right? Okay, nevertheless, so we know that this is basically the second half of the string, well, second half, the second part of the string, without the first character. Right. Right, say 2, so yeah. So we return 1 if we can call this function recursively and it will return 1. Basically, this, so we expect unless any. So right, so we removed all the characters by just chopping these characters here. Yeah, I wouldn't say that I understand how it works on the bigger scale. If we could not do that, unless any of these, right? So basically all of them should be empty, right? Or not. And if we couldn't do that, we return 0. Right. Raku, Colin Crain, Raku, Ch2. And our correct input. Wow. So here are the possibilities, which is really good. The output is 1, like this is right. So there are some attempts and they failed, but let's look again at the correct example. So these are our inputs, and you see how it changes. Took X target. Now this string, so we remove this one, right, from the second, well, from the third string, and actually we removed everything, right, from the first and from the last strings. After that, we try to append to remove X again from both, but you see, so B still keeps the same value. After that, we're done, right? But now XZ, now they why is it XZ target? Yeah, because this is a recursive call, right? And we do the same, which, yeah, we just picking the first character from the first and the third strings, right? But this is already here. Okay. Right, so we see, so the taken and the other, so if we start with A, then on the second thing, it basically comes, the other string comes here, the second argument, right? Yeah, okay, yeah, that's the brain puzzling solution, but it obviously works. Then go next to Athanasius. So again, interleave, the big function, and the explanation function, and the usage function, and where is our main entrance? So it's here. So what we do here, there's the string sequence and interleaved. So yeah, right, again, the same check. And then this call to interleave, success, length. So we map the strings to call the .characters method on them, and we receive the lengths. If the length is 0, if the length of the second string is 0, actually length square brackets A, what is that? So this A is obviously not a variable like $A, and there's no signal-less variables here in this program, but there's this enum, you see, so ABC, so yeah. There are lengths, and we index subscript those with this enum, right? So if there's nothing in A, right? So base case 1, base case 2, recursive case. So then, so basically, if the string is empty, then if the second string is directly equals to the third one, then that's result, and the same for the second string. And otherwise, but when basically these A and B are not empty, there are still a couple of cases. So we take the first characters and we saw this just in previous solution, the first character and the tail. The same for the second string, well, actually for the third string. And if this is already this, if the first character matches from the first string, then we do something. We push, I don't know. So success is actually, okay, so recursive case, and this is for the second string, the same thing, but for the second string. Okay, so I think, right, I wouldn't say that I understand, like, on the bigger scale how it works. This kind of solution, the recursive solution, but recursive is always a difficult thing. Athanasius Raku Ch2, and I need to find the input here. It is right. So input output is 1, and explanation. So that's cute. That's so cool. That's so cool. So this is the best output we've seen so far today. So I see immediately where this second string should be inserted, and I wonder if we will swap the things. Right, so that's cute. That's really cool. And like finally this one. Right, so this is great. I like it. Right, okay, that's good. So going next. The next solution in the list is a solution by Simon Proctor, Raku number 2. We take the strings and any of possible interleaves, basically again, so A, B, and B, A, matches C, then we print, it's again the Boolean thing, right, converts to integers, right? And possible interleave is, so we scan the indices, codes is basically the same as chars, how do you read it? So the number of elements, characters in the string, and we map those indices to what? So there's, so X is out, what is out? And this is sub. So it's an outer string and this is substring, if I'm correct, right? So X, and then we replace, you see, substr RW, it's a very handy thing to find the substring and replace it with something, not necessarily with the same length. We replace it with sub, and we basically try to insert the substring into this outer string at all possible positions, and after that we get this array or list or sequence, whatever. Well, it's, what is it? It's the result of map, right? And this is a range. And after that, we flatten that together with the opposite thing. And if any of those is there, we basically get true or false. That's cool. I like this. Raku Simon Proctor, Raku Ch2, Raku, and this one. And this one is 0. That is correct. Right, okay, so Philip Hood, Raku 2. So there are some defaults in the input. There are 3 variables as usual, and what's here? Definitely, probably you can just copy paste that, but you probably can create the function for that. But that's a separate issue. So this -1 can be replaced with hat here. But again, basically what we do here is chomp. Wow. We create some kind of arrays of characters, right? Because these are the indices, and these are the functions, the pointer blocks, where we convert the index, which is k, as the signature here of this pointer block, and we take one character to that position. So, but basically, what is that? I wonder what is actually that. Is it just this? Do we just get the array of characters, or I'm and actually chomp what this chomp is doing here. Maybe let's just try. My A is ABC, right? And like this, and say, well, maybe even DDA just to see the structure. Right, so everything is here. We can run this program. Raku t.raku. Right, so basically, wow. Yeah, that's, I think, overcomplicated, because definitely what you have to do is this comb, right? Right. So it's exactly the same. Okay. Right. Nevertheless, but actually, yeah. Again, this is the kind of the lack of educational materials or something like that. Because how do you know that this function exists, right? How do you split? So yeah, that's a separate thing to think about for the Raku community. Right. Okay. After that, while there's something in at least one of those character arrays, because we're going to take elements from those, actually just remove, and it's not saved anywhere. What we do if this number of things is no, if there are some elements, probably this dot elements actually neither here is needed, right? Because yeah, in a Boolean context, it will be true or false in any case, right? And if this head and head, okay, so yeah, and the first characters are the same, then you remove those. So yeah, we saw this kind of solution. And after that, and we do the same for the second string, and last if, so yeah, again, I now understand that. We break if the reconstructed string gives us the desired string, and after that we basically see how many characters remain in those strings, right? So if we manage to remove everything, because we remove either from A or from C, but actually it looks like it will find a combination where you split the string B as well, right? So you can split it into characters and substitute somewhere in between, right? So yeah, okay, so that's the separateness. We saw this with remember that big solution which also produced some really big output. I think this is yeah, like this one, right? So okay, let's run it. In any case, P K M P K M, right? Raku Ch 2 and some not that much. Right, so this is it, and this is it, right? Okay, this is incorrect. Well, I mean, that's correct, that it's incorrect, and this is correct and correct. Good. Right, yeah, maybe this is not quite Raku-ish. But nevertheless, we are satisfied, and I'm going to Markus Holzer, Raku number 2. Right, so unit submain, so there are three strings, and we immediately check that the length of the third string is the sum of the lengths of the first two, right? Then there's the interleave function, interleavable function, and we call this function, we pass those strings to it, and we also check the opposite, the swapped first two strings, and after that we just basically, yeah, this is true or false, and this is 1 or 0. Right, so what this function interleavable is doing. So, right, so this closing bracket is the end of the function. And this is the block of grep. And this is where we return basically true or false, depending on the what grep finds. Right, so what do we grab? Actually, we grab this, and this is the range 0, 1, 2, 3 up to the number of elements, not including the number of elements, characters itself. So yeah, we just scan all the indices, and what we do, we check if we can build the string C out of these parts, right? So this is the reduction reduction operator of with string concatenation, and we basically concatenate 3 parts, 1, B, and 3. The first thing is the substring up to this index. $hat_I is the placeholder variable, and basically it takes the value of the current index in this loop, organized by grep with this range, and this is basically all the rest. So yeah, basically if we can insert this string somewhere in between, and the important thing, unlike the previous solution, for example, that we insert the whole string B, we do not split it ever. Right. Okay, yeah, that's clear what happens here. Raku, let's run it. Raku, Markus Holzer, Raku 2, and if I have it in buffer, it's 1, and this is 2, and this is 0. And again, if you swap, I'm sure that this will just work, right? Yeah, because right. Good. Mark Anderson, Raku 2. So yeah, again the same check immediately, but yeah, actually probably we have to look here again. So we see where $C.chars equals $A.chars plus $B.chars, right? And here in this Mark's solution, we see that we have this $A and $B here in the same place, but here we just use the default variable, which is basically referring to the $C. Okay, this is interleavable, is interleaved. Okay, dash is here. Right. So you return 1 immediately if all those strings are empty, right? Because you insert this equals in between, basically here, here, and here. So you've got number of characters in A and B and C equals 0. Okay, weird case, but yeah, why not? But I wonder how you can insert. Will it work? So Raku, Mark Anderson, Raku 2. So basically, do I do it like this, or probably yes, because otherwise I will get the exception. Wow. Okay. Right. Actually, I didn't think about this case. Return 0 if there are no characters in the C. That's obvious. No, but how can we reach this line? I mean, how can we return 0 from this line? Because if this is 0, then this sum is 0, and okay, so one of them is no. Then both should be 0, right? Because we cannot have negative. So probably this line is extra, if I'm correct. Okay. Nevertheless, yeah, that's minor things. Here. What we do here, we take the first characters of each, right, and we take the tail of each string just in one go. That's smart. And yeah, of course you can use arrays, but yeah, you can also give names to these 3 variables. It's clearer to use these names, right? And you return again. Basically, it's 1 or 0, either 1 or 0. Yeah, I wonder if we have number here and we have or operator, like for example +1 or 0. Yeah, it's 1, right? So it's not true or false, because it just returns you the first, right? The first non-zero, well, non-false element, operand. Okay, so if A equals C. A, yeah, because A is not the string is capital A, and basically, yeah, here we check basically which path to go. If we see that the first character is the same as the first character in the result string, then we call this, and after that we call that. Okay, and finally the interleaved. Okay, that's recursive call. We saw this a few times, but this I think is the most compact solution so far, the recursive solution. Good. Okay, so we can run this finally with some real strings, and it gives us 1, and this gives us 0. Good. Kang-min Liu, Raku number 2. There are 3 strings and the interleaves function with 3 arguments, and it returns obviously some boolean value, and we replace it with 1 or 0. There's some stash which we so stash push -1 -1, while there are some, while what we do here in the while, probably $I is the counter, but I don't see where we actually modify this. Return I is here. So we take the current symbol or the current character, right? Iteration. On each iteration, after that we gather this stash from the elements that we have, basically again to what is IT? IT is this. Oh, I don't understand that. So probably this is somehow like we try to create the window and move it, and basically this stash keeps the indices of that window, right? If I'm correct. If C equals B, then we take these indexes, and the same for A. Okay, but A is 1 character at the current position. Okay, and return if we reached the length of the required string, and if there are some elements in this stash, and right. So yeah, okay. So and if this right, yeah. Right, that's I don't quite understand, but Raku, Raku, chat 2, and some strings. That's one, and I wonder what I can, for example, what if this one is like this and this one is like this, right? Yeah, it's too many x's, I believe, right? Yeah, okay. So yeah, I mean, okay, and what if like, yeah, okay, this is the case that we saw already. Okay, good. Going next. Krnavek, Raku 2. So we start here. Well, I will skip this function for the test mode. So interleave what and from, and okay, so we should enter the 3rd string first, I believe, right? Yeah, from this. Interleave what from named parameters. Oh my god. Okay, so we create something, what is it, signature, right? And then we apply this to this methop call of this one of these 2 multi-methods. And okay, so the step, what is the step? And wow, 3 dots bool. What? I don't understand that. So this is obviously a range operator, right? And Raku. So for example, yeah, if this returns as true, true. Really? True. A, what is it? This is a bool. But I mean, basically this is kind of the same, right? But what's that? I don't understand. The sequence of 1, right? Sequence containing 1 character. And here is the sequence containing 1. Okay. Really? What's that? Docs, Raku, org, sequence operator. That's good that we can search for these characters, not necessarily. So, no, not necessarily characters like text characters. Yeah. So, okay, so yeah, I didn't understand that. What does it mean when the sequence operator, one of the operands is type, right? Right. Otherwise, so yeah, if so this true we get if there are no elements in either, right? Right. So, but if there are, then we use this one, and from first, and try to find first character, which is the same as the first character from the second thing of here, right? Of here, sorry. And K means that we want to use to find the index of that thing, not the character in this case, right? Then we create this signature, capture. It's not signature, right? Capture. And what's that? Yeah, this is a high level. Yeah, capture. Raku. Basically, it's kind of hash which you can use here. Yeah, I will not understand that probably. Right, and but nevertheless, so when we get here, we like here, right? If we start with this multi-function, and the difference between these two multi-versions is that this is a string and this is an array. And here we just call the same function with different thing. Yeah, basically probably we will start with here if we have the string here, because this is string, and then we replace this what with comb, and here we have an array of characters, and then we call this function. Not necessarily, well, I don't understand why actually we need two different multi-functions with so different kind of arguments, right? So it's a bit strange for me, at least. Okay, nevertheless, what I propose to do is just to run this program, one bash raku to raku, and pass this test example. It should print false, because this is already broken thing, and this is the original one, right? Everything is false. What was there in the task? Interleave strings, interleave, right? So xxy, xxz, xxy, xxz, and this is right. Wait, but it doesn't work, or I run it somehow differently. Ah, of course I'm running it differently. This is how I'm supposed to run this, right? Yes, now it's true. And for example, if it's xxx, it doesn't work. I mean, it works, but it returns false, right? Okay, so it seems to be correct, but difficult. And Feng Chang, Raku 2, interleave string, right? So it directly calls the, it splits the characters into, split the string into characters and passes it as a list. And you see, so you get list in scalar variable, and this function returns as an unsigned integer. So if there are no elements, you return, yeah, basically, yeah, depending on if there are some elements in this. Yeah, you see, so this is OR, but this is not a Boolean thing, right? Because we compared with, yeah, but this is what we just saw. Again, like 5 or 4, either 0, it's any of 4. So yeah, it's a junction, and we can basically, if any of these lengths is bigger than 0, then we claim that there are no matches, right? Right. Yeah, but actually, yeah, I think this vertical bar can mislead sometimes, like I just did a second ago. It's not OR, it's OR in some sense, but it's a junction, right? Yeah. Don't forget about junctions. But yeah, so yeah, if you will do it like this, it's already a shortcut OR, right? Okay. Right, so return 0 if some other things. So yeah, this is the defined OR operator, and if this equals to the first character, right? Because here we work with lists, and we can subscript it. It's not the string. Again, I still completely don't understand why you cannot subscript the string directly in Raku. But yeah, this is what we have. Return 1 if recursively call for the tail. Yeah, so basically we try to find different positions, and these different position will differ because in the next recursive call we will already have different A, right? And the same for the B. Okay, right, so Raku, Feng Chang, Raku, 2, Raku, where we have the correct string, like this, for example, right? Right, and this is incorrect, and this is correct. Good. Arne Sommer, Raku number 2, and there's one solution left. So 3 strings with at least one character in each. Yeah, we don't want empty strings. That's yeah. And do check. What it does, it requires one if. Ooh, but it cannot happen, right? Because here we state that it should contain at least one character. If that's so smart, I think it's the smartest thing I saw. Well, one of the additional smart thing, additional very, very clever solution. This is a clever decision to this. Just immediately to check if the string is there, then just try to find it there. Right, and the same for the second string. But what we have here is substitute. So ABC are strings, right? You substitute A, but where to? Where to? So if, for example, Raku ABC subst DEF, what happens here? Yeah, and there's a small update for the same solution. So let's run this with a bit fresher. So I have this, it's not Rakudo Star. So the latest Rakudo Star is from January. And here I have another version. It's not the latest, but it's still much, much fresher. And let's run this with this, and also you see -v is there. So here's the solution. So basically the code compiles now with the fresh. Actually, I think it's probably the first time that I see that quite fresh Rakudo Star doesn't work with some construct of this solution. Okay, so yeah, so we see the steps and the result. Okay, yeah, let's continue. Okay, finally my solution, Raku number 2. So here it is. So I take 3 strings from the input, and actually, yeah, so I have this part of the program just to, because yeah, it was not quite clear for me. Can I swap the strings and can I put it inside? But basically I print 1 and return from, yeah, basically I return as soon as I find it. So I scan the indices in the first string and I print 1 and return immediately when I see that I can put this string B inside string A at some position, right? So yeah, I split A into 2 parts and put the second string there. Okay, Raku, not here, Raku, Ku, Ash, Raku, 2, and, oh my god, Raku, Ash, Raku, 2, Raku, XX, Z, XXY, XXX, XZY. It's 3, so we see, so this case, basically, yeah, it's the case with, well, it depends on how, this is one, this is the first case. Okay, so that was it. So yeah, there's still this subs thing to understand, but it was really interesting challenge for this week, from this week, Interleave strings, and we were looking at the Raku solutions. Okay, thanks a lot, so hope to see you next week. Goodbye.